it's now time for our second keynote speech of the day. I wish to thank Professor Izhak Rubin for being with us. And he recorded his presentation, which is available on the web, and I hope you all watched it already. Very interesting. So before opening the discussion, let me introduce Professor Rubin. I'll read his bio. Joining the UCLA faculty in 1970, Professor Izhak Rubin has been serving as distinguished professor in the UCLA Electrical and Computer Engineering Department. At UCLA, he was the recipient of an Excellence in Teaching Award. Professor Rubin has been engaging in research, consulting, and industrial projects involving in the design and analysis of commercial and military computer communication, telecommunications, and networked autonomous mobility systems. He has been publishing papers in leading journals on a wide range of key communication networking topics and received Best Paper awards. He has been instrumental in contributing to projects that include air traffic control, mobile wireless network, cellular cross-layer operations, mobile ad hoc wireless networks, autonomous highway transportation systems, UAV-aided wireless networks, and adaptive video streaming operations over wireless networks. During 1979-80, he served as acting chief scientist of a Xerox telecommunication network. He has been organizing and chairing a wide range of conferences and workshops and served as co-chairman of the 1981 IEEE International Symposium on Information Theory and as a program chairman for the 1987 IEEE Infocom Conference. He has served as an editor of a multitude of journals, including the IEEE Transactional Communications, Wireless Network Journals, Optical Networks Magazine, IEEE JSAC issue on MAC techniques, Photonic Network Communication Journal, and has been contributing chapters to text and encyclopedia of telecommunication systems and networks. Dr. Rubin is a life fellow of the IEEE. And the title of his keynote speech is Communication Networking and Traffic Management for Autonomous Transportation Systems. And I'll take advantage of being the one who speaks at present to ask him, what is your view? I mean, autonomous transportation, autonomous vehicles have been around since the mid-80s. I remember at that time, Daimler-Benz started the Prometheus project, which was a visionary project containing many of the ideas that we are still looking at today, like platooning, like many things that are now starting to appear. But while the vision of Prometheus and the vision of many of the research works that appear are based on extensive communications, what we see in place right now are mostly features of individual vehicles. So can we expect this scenario of fully interconnected vehicles happen anytime soon, or we still have to wait for a number of years?
It's a pleasure being here, so online, and nice seeing all of you guys. And I've seen Renato recently in Los Angeles in a IEEE workshop on wireless network, and that was a great pleasure. And very important for me to remind everybody of the person that founded the MedHawk conference, a very good friend of mine and of many of you, Mario Gerla. And also say hi to Maggie, his wife, who is here, I see. And we miss Mario a lot every day. As I walk in the corridors at UCLA, I see him very often. We talk about various things, and I don't see him anymore. Aside from that, Marco, yeah, that's a good question. Since I have been working over the last, I don't know, 10, 15 years on the wireless communication among vehicles, for about 5, 7 years, it wasn't autonomous. It just was communication between vehicles, trying to find some other mechanism. You know, at the time, 802.11p has been around, still implemented by various companies. Of course, cellular, millimeter wave, all takes over. We liked playing with it, but obviously it was pretty clear that you need eventually a stable infrastructure for communication networking which has sufficient bandwidth. Because if you want to rely on an autonomous communication network, there's a lot of information that vehicles have to inform each other. Aside, obviously, from the still open problem relating to security and so on. What you're asking is very interesting. First question, everybody asked me, when would we have? Well, there is no definite answer because it's coming in a gradual fashion. Not today they are talking about getting out of the pandemic. Should it be a U shape or a V shape recovery? But it's not a V shape recovery to get autonomous vehicles. So about a year ago, I bought a Tesla. And as when I bought it, the guys that sold me the Tesla told me, well, you know, this is a kind of self-driving car to some extent. Do you want to buy the package? I said, okay, I'll buy this whole package and so on. So let me drive with you on the highway and see what it can do. And what it could do, and it demonstrated to me, is it could switch lane on its own. So you can push some button, and moving on the Los Angeles highway at very high speed, it kind of estimated whether it can go between two cars moving at very high speed in a neighboring lane, and it did it. The guy was sitting next to me. I never tried it again, by the way. When is it going to be here? A lot of challenges, as all of you guys know. Many of you have been working in that area. Now, when I talk to different companies around, I have been spending a lot of time with Caltrans, with engineers and managers at Caltrans. Caltrans is the California Transportation Authority. It's a big one. And I talked to people for the last couple of years in the Los Angeles branch of Caltrans. It's a huge, huge building in downtown LA with a lot of stuff going on. And I presented them some of our studies, talked to them what they want to do on the highway, asked them how is traffic regulated today as accessing the Los Angeles highway, and what are the measurements and criteria they use to optimize traffic on the Los Angeles highways. So they referred me to some guys that built it for them, so I went and visited them, some at other universities, and they basically want to maximize the flow rate, but nothing is very sophisticated. So what they are interested is obviously they would like to increase the capacity of the highway without investing too much additional money, and to get reasonable delay times on ramp and in traversing the highway. Obviously, that's what they want to get. And the point is, in order to get something close to it, we need to start now, and that was my general idea in these studies. We need to start now to figure out how is a system of autonomous vehicle going to work. How do you regulate the traffic? Assume you have communications between the vehicles. How do you take advantage of that in order to obtain performance on the highway, which is significantly better than what we have now, and to what extent would we get it? When I talk to the manufacturers, the vehicle manufacturers, and I've talked to some of them, they say, well, we don't care about that, kind of. I mean, not exactly they don't care. They basically say, the authorities, the local authorities, the city authorities, the county authorities, the federal authorities, there's a lot of levels of people. They have to put some regulations, and in order for all of that to work, the vehicles have to be able to behave in a certain fashion. So in answering your question is, we are lacking an overall system-wide modeling and analysis, even if to start with, it's highly theoretical, by assuming, for example, that all vehicles are autonomous, or assuming that are semi-autonomous, or assuming that some lanes are autonomous and some are not, or taking even just the trucks. There's a lot of experiments going on in Los Angeles and elsewhere of trucks being fully autonomous going on dedicated lane, even looking at that. And I have been talking to the US Navy, and they wanted me to study for them autonomous ships and boats and so on, and that's a relatively different problem. So we need a system-wide study.
Okay, so let me repeat again to the audience. If you wish to ask a question, please reserve on the chat. And I see we already have a question by Michele Segato. Michele, come up.
Here I am. So thank you for your keynote. It was also very interesting. Following up on the question from Marco and from your answer. So in my understanding, traditionally, vehicular networks have been built bottom up. So we needed something to do vehicular networks, so 802.11p came out. And we started to do some analysis. It might not work in some scenarios. So what about using cellular? What about using visible light communication? What about creating a dedicated cellular V2X standard? What about using a millimeter wave? So it looks like we are trying to adapt the technology without having a clear idea of what we actually need. Connecting to what we have been saying yesterday with Leonard Kleinrock, it looks like to me we are trying to do over provisioning on communication technologies to try to support the application. Do you think there's room for inverting this trend? So starting top down, first define clearly what the application is, what the application needs, and then going down the stack to finally define the technology that can support this. Do you think it's feasible, or it's a crazy idea that it's too complicated to be done? What is your opinion?
So basically, that's a very good point, and I think that's how I structured my presentation. So in the first part of my presentation, I talked about the objective. I didn't talk about technology. So I assume that there will be some communication networking technology that will enable vehicles to talk to each other and to talk to roadside vehicles. And my question is a traffic management question. What do you want to achieve in an autonomous highway system? And I posed an optimization problem and presented some solution based on some assumptions. And the optimization problem is the following. Assume that you have a highway that consists of segments that are connected in a certain network, and assume that you observe vehicles flowing on the highway, coming on ramp, waiting in multiple lanes, admitted to the highway using some admission control mechanism, and then navigating themselves on the highway in a certain stochastic fashion, which is generic enough. And now the question is, okay, given that you have an autonomous system, and given that you know, theoretically, the speed of vehicles coming in, the speed of the vehicle's highway, what's the interest of each vehicle, where it comes from, where does it want to go, what is approximately is targeted arrival time at the destination, what is the best way to manage the traffic in order to maximize the flow rate across the highway, given the constraints of not waiting on ramp more than a certain period of time, and having a targeted transit time on the highway from source to destination, which is around some given number. So this is the generic problem. That's really what you want to achieve. And then comes the technology below that. How do you go about achieving it? Would this communication technology will do it? Would the other do it? And that's the second part of the paper. And then the third part is, are the trade-offs here? If I design the network to achieve my traffic management objectives, and then I try to build with a certain technology, which is changing all the time, a communication network system, would there be a trade-off? Would I have to compromise on some dimension in order to improve the other dimension? And that comes the third part. But the first part, which is still open, myself and my co-authors, obviously, Professor Andrea Baiocchi and the rest, we spent several years putting together a definition of what is the objective of an autonomous highway? What do you really want to achieve? Once I got some initial result, I went to Caltrans and I told them, you know, if I add an autonomous highway, I can get on the 405 highway in Los Angeles, a very busy one, the San Diego freeway, I can get you that many cars per hour. Would you get excited if I get you this number, or that's not such a big deal? The guy said, wow, that's amazing. That's some kind of a factor, I don't remember, higher than what we achieve now. They care about the flow rate. Now, the real optimization problem is more than the flow rate, because you can achieve a high flow rate by getting cars to move very slow and taking hours to get to the destination. And that's not the proper definition of the problem. The other thing is to observe that once you start developing a system theory, there are very interesting trade-offs. If cars have to move sufficiently fast on the highway so they get in time to the destination, they have to keep sufficient distance from each other. If they keep sufficient distance from each other, the density of cars on the highway is low. The transportation equation tells us that the flow rate is a product of the speed of the vehicle and the density of vehicles on the highway. And it turns out that if you play with that, there is an optimal number. There is an optimal speed, which we presented in the paper, without delay constraint. And then it gets more complicated. There are optimal speeds with delay constraints, waiting on ramp and transit time in the highway. And it also depends on the routing metrics, or how vehicles flow across a regional network of highways. They move from one road to another. So it's highly appreciated what you just said, that you do need a system here.
Thank you. Thank you very much.
More questions from the audience?
I know that Falco has done a lot of work on vehicular networking. Falco, what do you think?
It's actually, well, first of all, thank you very much for your really interesting keynote. I enjoyed watching the video very much. It's actually a pity that I spent so much time with Mario all the time, but not really working with you so far. But at least I enjoyed the time with Mario and the many discussions on vehicular communications a lot, like I did for your keynote speech now. I think one of the key problems in our field, working in vehicular communications since a while now, and also looking back to Michele's question that he came up with, sure, we look from the application perspective, is that we are still struggling seeing many of these applications on the road. So even though we have been working on that since 20 years, and very, very few of these applications came to reality. And what I really think about over and over again is why that is. And so we have seen a lot of effort from both car makers and also governmental agencies to push into not just creating standards, but also making part of this mandatory safety part of our cars. But well, we all know the stories. Some of these activities have been cancelled again by current governments. So I'm really not sure how this moves on. At the moment, I see very little push from the car makers pushing for safety solutions. What they are looking for is more these I don't know, the short time selling solutions. What you I don't know, the next fancy parking space finder and the next fancy I don't know, coordinated access to some data. But this is not really in line with all our research efforts that we spent over the many years. So, long story short, my main question to you is: do you think what do you think we as a research community, worldwide research community, can do to stimulate this process that car makers and governmental agencies already started to move it up again? So, I don't know, writing a big banner, do something is probably not good enough, but what do you think? What can we do? We together, worldwide researchers.
Well, I guess we have to keep pushing it, because eventually there will be a lot of good coming out, and it may not be in the ways that we foresee it right now. It may not be initially a whole global autonomous network. It may be subsystems of that nature. And there may be other benefits. For example, 2 years ago, I worked with the School of Public Policy at UCLA. They gave me some grant, and I went to the School of Public Health, and I said I would like to put as part of the optimization problem pollution. So I found a professor at UCLA who has been publishing a lot of papers on measurements of pollution in the Los Angeles highways, a function of various things. It turns out, it's quite interesting, as you increase the speed of the vehicle, pollution goes up. But when the speed of the vehicle goes below a certain level, the pollution goes up again. So that means if you have a lot of vehicles waiting somewhere at the intersection or on-ramp waiting to go up, that's actually not good. That causes a lot of pollution. So that puts some kind of weights on the optimization criteria that you will like to invoke in optimizing your system. And if you have communicating cars, and if you can check what's the pollution levels of different cars, you can probably reduce pollution in a significant fashion. But that's an open problem. That's yet to be studied. Now, who is going to pay for it? I don't know. That's a different story. I was trying to get all kinds of agencies to pay for it, but these days there's other priorities for public health officials. But one day, I think this is important. Now, another thing that people ask me, I went to the School of Public Health, and those guys are advising localities, the cities, and they said, wow, if you're going to be successful, who knows when, and you're going to have an autonomous highway and everything is going to flow very efficiently, that may cause a lot of congestion in the locality. A lot of vehicles are going to drive around looking for all kinds of ways to optimize their way of getting around based on what you're doing. Don't you want to take into consideration? But that's quite interesting. I don't know how to do that. People have observed that to be the case in Uber and Lyft. They drive next to your house for some reason because they get Waze or whatever optimizers that tells them, you know, the best way to go is go to this small neighborhood and go see that. But that's another interesting question. So, I mean, these are all open problems to be studied.
This is very interesting point that you bring up, right? When you try to optimize, then there's always a different consideration, actually, what you optimize, if you optimize for the single person, the single car, the single driver, versus you optimize for the good for the benefit of all. Where you have to have a single driver sacrificing, at least in some metrics, in order to, for example, improve pollution situation for everybody, or also improving the travel time situation for everybody. And this is also maybe a challenge for us as a research community to tell people that sometimes taking a sacrifice for the good of everybody is, well, it's very important actually. So we have to consider that, but people are selfish. So when you look at particular drivers are selfish, very selfish. Taking any sacrifice is maybe not so acceptable. So we need possibly also to work more on public acceptance questions in order to bring our optimizations into the world.
That's a very good point. Here's another example. In the US Congress, they are talking about an infrastructure bill. That's of the order of $1 trillion. Actually, eventually it will be several $1 trillion. It's a lot of money. And they wanted to focus on highways and bridges. They say it's a long time since we renovated, and there's a lot of congestion on highway and bridges. So you can help them, you can save a lot of money, you can reduce the need of increasing the capacity of a highway by having more type of autonomy on it. But the question is, how do you go about it? Well, that needs to be studied. And that will attract their attention. If you tell them you're going to save a few $100 billion, they say, oh, it sounds interesting to me. So there is a possibility here. There's a lot of possibilities in this direction.
Okay, we have Anna and Edmundo. Anna first, because ladies first. Edmundo, I'm sorry, you have to wait.
Oh, I'm sorry, I didn't see Edmundo's question. I thought it. I wanted to follow up on Falco's point about this. Whom you optimize to. We have a project which is ending now, and we are writing up the final paper on exactly that point, which is we're doing a kind of a optimized routing, but not optimized for each vehicle, but optimized for a fleet of vehicles. And the idea is that you start the cities can start talking to fleets like Uber or like all this, or taxi fleets or logistics or whatever, and try to have at least those reach a trade-off. And even the trade-off is not an easy one, because you don't have only the time and the emissions, then you also have other kind of indicators like the noise and the whatever. There's many. So there is I think that this is sort of moving, and also leveraging these autonomous vehicles, which we don't know when it will come, but at least looking at the fleets and looking at the more shared, if not necessarily public transport, but shared mobility, right? So, but sometimes I'm not sure. This is done in transportation, and I wanted to ask whether Falco means that what it meant in regards to transportation or to networking. So should we start thinking about this also this way when we think about networking, which is what we call fairness, although fairness for us is equal. And again, if you look at transportation, it's not necessarily equal. It's a multidimensional stuff. So
yeah, actually the terminology can be confusing. I tried in my papers to differentiate between vehicular throughput and message throughput, because there is networking in both dimensions, in the vehicular dimension and of course in the messaging dimension. Yeah, but these are very good points. What should be the optimization criteria, and how much would the individual should pay for the good of the community? In what sense?
Okay, Edmundo, your turn.
But a very interesting talk. I'm not working in the area, but I enjoyed very much. And I have a question. Maybe it doesn't make sense, but just to clarify, we probably are going to see more and more autonomous vehicles in the highways. Like take like LA to be simple. there will be a mixture of autonomous systems and regular cars. So is there any study saying what is the impact as the fleet moves to autonomous systems? Would you expect to see an increase in throughput right away? It's going to take some time, some percentage of the whole fleet to see that improve? Do you have anything in that area? If the question makes sense, also.
Yes, it makes a lot of sense. And actually, we have formulated such a problem about a year or 2 years ago, but we still have to work on it. And the question is, what percentage of the capacity of the highway should you dedicate to fully autonomous car, to semi-autonomous car? What if you're not fully autonomous, but you have ability of certain vehicles to communicate with other vehicles or to share their status or sensor messages, and some cannot share the status messages? How should you mix it? Should you isolate certain lanes, dedicate them just to autonomous or partially autonomous vehicles and others? These are generally, I would say, open problems. From a stochastic point of view, you can study them because by having a partially autonomous system, you get more stochastic variation in the system, and you can calculate mathematically what would be the decrease in the throughput efficiency of the operation when you are not fully deterministic based on some manager optimally managing the system. So I would say yes, this is a good question, and it's a very practical one because we're not going to become autonomous instantly. It's going to go through phases. Dedicating some lanes to autonomous or doing other things like that, that's people have been talking about that, and that's an interesting question. Yeah, so definitely.
Look, thanks a lot.
Sure.
So nobody pops up from the audience, and I'd like to follow up on a bit on the many comments and questions around, and I want to hear your opinion, Izhak, on this. On the one hand, we are discussing the fact that there is a global optimization which may be several times better than what we do today for road traffic. But this, as Falco was saying, might touch somebody. So somebody who is faring fairly well now might be penalized somehow. And besides this, my impression is that we are scientists are mostly talking to car makers on the one hand, or cellular makers on the other hand, and both of these industries are not addressing societies, but are addressing individuals to give them something distinct. I'm thinking of your Tesla, Izhak. It was a real pleasure driving with you around Los Angeles in the Tesla, but that's not exactly, as of today, low-end popular car. So Tesla is touching on your ego somehow to sell it, and not to the global optimization of the world. While at least in Europe, we are not taking to society. I don't know in the US, but we are not talking to society, not even to lawmakers. You talk with the traffic of California, traffic regulators of California. So aren't we making some mistakes in what we are targeting with our research to bring it on the market?
Yes, definitely, I agree. And I would say, since I was trying to talk to society, that it's pretty much the same thing here in the US. So we need to talk to them more. Well, you heard in Len Kleinrock's talk that one thing that is missing if you are going to redo the internet or modify it to some sense is you have to now start talking to other types of people, start talking to social scientists, because that touches them. Now, there is a lot of truth here. Obviously, there is an opposition to autonomy, as you may know, and to AI in different segments of society. people are going to lose jobs. There will be a lot of transformation. There will be a revolution of a certain type as you go to more autonomy, and there is opposition to it. There are a lot of demonstrations against doing that in the ports, in the harbors, and so on. And that's a societal problem. And obviously, city and regional and public authorities are very sensitive to the feedback they get from the people. So you have to be very careful in studying things. So what I was trying to do at that point is just study it in a general system-wide fashion first in order to see what are the different trade-offs, what are the options. And the next step is to get what you say, to get the social scientists. And I've been talking to the public policy people. We have an Institute of Transportation at UCLA in the School of Public Policy, and they have been very active in talking to city and county and federal people. But when you talk to them, you see that their level of thinking is not as progressive as what we are talking here about. Because as scientists, we have to push it forward. We have to make some assumption, assume that you have an autonomy to a certain level. What would you get out of it? What are the trade-offs? And then you can come a little bit down from it. But how do we get those people to cooperate with us? You're absolutely right. The car manufacturers, they don't think it's their problem to think for the city and for the county, and to come with generic standards that have something in them which is for the good of the public as a whole. It's the role of public authorities to do that, but somebody has to advise them to get more active in this direction. And that's something that we need to do.
So if nobody comes up, maybe I can ask another of my curiosities, which is, what is your opinion, Izhak? But I'll be happy also to have the viewpoint of Falco and Renato. What is going to happen in this universe of technologies which are essentially on one side Wi-Fi based and on the other side cellular? How will this technology coexist? Will they share a market? Will they somehow fight each other? What do you expect? As the researchers, should we look more at the direct vehicle-to-vehicle communications, or should we more investigate the impact of cellular on these autonomous driving systems and the like? I'm asking this because I see a big clash between the two domains. I mean, the cellular operators think that they are going to carry all the traffic for all of these services, whereas there are other industries that have a very different view. And I'm kind of curious to understand where a researcher should better investigate his time in order to make an impact.
Yeah, that's a very interesting question, and there's a lot of discussion in the literature, and there are a lot of paper comparing. We did some comparisons in our paper based on a variety of assumptions. From the beginning, it was pretty clear to me and to many others that in order to get a robust, stable, and reliable autonomous system, you need sufficient capacity, communications capacity, aside, of course, from higher capacity. And that Wi-Fi on its own is not going to provide you, and certainly not at the bandwidth allocation, the spectral allocations that have been used before for experimental purposes. Now, there's a lot of investment in 802.11p, but eventually a lot of bandwidth is needed. So it looks like you'll have to move elsewhere. If you want to be serious about it, you need the status of each vehicle to be distributed to other vehicles within a very short latency. You have to know what's happening around you. How can you trust otherwise an autonomous system? And there isn't the capacity there in a Wi-Fi 802.11-like system to do that, and neither it is stable enough. So for a while, we use it in order to learn a little bit about the system, but eventually we have to move elsewhere. Having said that, and there is a potential for cellular type system to do it. Now, the cellular system needs a lot of capacity as well. So that's why we're talking about millimeter wave. And as you just heard in the previous session, we're not there yet. There's a lot of challenges in millimeter wave communications, and this fading and everything else things disappear on you. And of course, the directionality of the antenna and so on is an issue. Having said all of that, you do need vehicle-to-vehicle communication even if you have cellular communication. I don't think you can disregard the need for it because of a variety of things that will happen. Theoretically, if you can always go through an RSU, through a base station, and within a tiny fraction of a millisecond go back and forth everywhere else, you're okay. But what if the base station fails? What if it is over-congested? What if it unexpected conditions? If you can communicate at a very fast speed to vehicles around you via millimeter wave or anything else, directly V2V, that could be highly critical. So I would say there would be a mix of the two, but the bulk of it will have to come from a infrastructure-aided system. What do you think, Falco?
That's exactly what we tried to convince many people already since many years. That exactly this mix of the technologies will be or needs to be the final objective, so that whatever is available can be used. But I also remember very well, let's say, not so nice discussions at some conferences where there were people coming from the cellular world and people coming from the wireless LAN world and literally fighting with each other. And I don't know, this is no scientific behavior, this is no scientific discourse, there was no good argumentation, and this is something I found very, very sad actually, and it happened multiple times. So this is again something where we as a research community need to think again of how we come to scientific findings and how we can show scientific results. And in the end, it is kind of obvious that none of these technologies is perfect. And the spectrum is scarce wherever we go. So we need to make the best out of this, use these opportunities. If there is a millimeter wave link available, this is very likely spectrum nobody else wants to use because this line of sight technology, so interference is probably at least rather limited. So if you use it, we will not, I don't know, kick anybody else. For all the other technologies, we need a good resource management. That is what cellular networks bring, which wireless LAN never had. So this is just, we try to optimize fairness, but fairness is not necessarily the good thing here if you have safety critical applications. So I fully agree with you what you were saying, that bringing these technologies together is the best way, and our job as researchers is to find how this control channel needs to behave in order to make the best out of the resources. So I fully agree with you.
Yeah.
So if I can intervene, go ahead, Edmundo.
Oh, it's just a quick point. So there's a lot of talk of people saying that when you get 5G, 6G, etc., we don't need anything else. From what you're saying, that's not true. You are going to bandwidth will still be scarce, so you need to use everything. Is that my correct impression from what you said?
Yes, it's going to be scarce. Plus, you have to have a robust infrastructure, a robust system. Things fail. Here you have soft failures, fading, losing communication, losing connections. Actually, there's rain attenuation. There's all kinds of things. I used to work in the 80s as a chief scientist of the Zero's telecommunication network. We made measurements at 10.5 gigahertz band because we designed radio networks at that band, and we filed with the FCC for frequency band there, and we eventually received it. But when somebody comes, that's changed our channel. When a car was moving along the street, that's changed our channel as well. So it's very sensitive to all kinds of variations.
Sorry, Renato, I jumped.
No, Edmundo, it's perfect. Actually, I was going to add something to this, which is not a real dialogue, because we all agree, which is very bad. Normally, you have good dialogues when people disagree and have different opinions. Actually, what I think is that in the end, if global coordinated traffic and autonomous cars, vehicles are to become a reality, you probably need at least 4 different technologies building communications from a car. You need cellular for global connectivity. You don't want, if you want to get a message to the police or anything, you don't want to have your message doing 100 hops car to car, hoping it gets there. You want a base station to pick it up and deliver wherever in the world. And this is looks to me sort of granted. At the same time, you want local communications, be it 802.11p or its evolution. Again, we are talking about the technology which is 20-year-old, right? So today with 802.11, we can do much, much better than 802.11p, right? So an evolution of that comes for free. And you were talking about millimeter waves, and any autonomous car has millimeter, actually at least 8 millimeter wave communications on board, which are radars, right? So why don't you modulate those and talk with the car in front of you, the car behind you, and there you have a lot of bandwidth. It's a purely local channel, car to car, and to this you can add visible light communications, whether based on main lights or with a small dedicated laser or LIDs. And there you have plenty of bandwidth dedicated to communications between cars that are close one another. So I think one of the challenges we have is to push not the fight between 802.11 versus cellular, but to how do we integrate communications for a global optimization, as Izhak was doing, delivering high-quality video over millimeter wave communications, which reuse the same infrastructure that we use for ranging from the car and so on and so forth. Everybody's saying, yes, that's not fair. You should kill me for these outrageous ideas, not say yes.
Well, basically, that's what we did in our millimeter wave study, what Julia presented. We assume that the vehicles are at fixed distance from each other, very close, and they have a millimeter wave communication channel that don't require a lot of aiming or correction very often. But then there are the challenges, because every so often the information has to go from a vehicle to a roadside unit, to the infrastructure. And there are challenges in doing that. So, yes. And then sometimes a vehicle in one lane wants to communicate with a vehicle in another lane. And we study that as well. So there are challenges in doing that as well. even with or particularly with the millimeter wave. A lot of challenges.
And the problem is that this integration scenario probably is something that we like as researchers, can generate a lot of interesting questions and so on. Mm-hmm. However, the whole area of car and traffic data probably has a big market. So you can remove the probably. Has a big market behind it. Mm-hmm. And many actors are very keen on tapping that market. So there will likely be some industrial clash between different types of companies and industries in order to be able to exploit whatever profits are possible from those markets. So the scenario that Renato was depicting before is kind of idyllic, but I'm not sure that the industrial players around are really so keen on cooperation and revenue sharing.
Well, there would be markets that we are not as yet thinking about them today. As we develop more this technology, there will be some surprises.
Yeah, I agree. I was very surprised when talking with some reasonably high-ranked person from a car manufacturing company. They were telling me, well, what we are considering is the fact that in the future we will not be selling cars. We will give cars away for free in return for the fact that drivers allow us to get their data, which is remarkably similar to what is well, not today, but since a few years happening over the internet. They are giving you services for free in return for your data.
In return for your
soul. And the fact that they are starting to think same for cars, I thought kind of weird, but car manufacturers are considering these options.
Let me tell you, over the last 2-3 months, I have not been using my car too much. So I don't really need a car right now.
That's another side of the story. Nobody of us has been driving anywhere in the last 3 months.
Yeah, but that's just temporary.
But we hope this is just a transient effect.
Yeah.
Not steady state. Okay, fine. Do we have other comments, questions, whatever from the audience? Here in Europe, it's getting close to dinner time. Thank you very much, Izhak. It was extremely interesting, both your presentation and the discussion. Of course, the topic is quite hot, so very many things to discuss around this. But thank you very much. Thanks for being with us. Thanks for accepting to give a keynote.
It's a pleasure. Nice seeing you all, guys. Take care.
What I didn't mention.